All right, we've got one more section to discuss today. So we're going to add in a couple more vocabulary words. So we need to talk about adjacent. First off, what in the heck does it mean to be adjacent? Huh? Beside. Side by side is what adjacent is. So if I have adjacent vertices, that means two vertices are side by side and connected by an edge. Okay, so there has to be an edge that connects two dots for them to be adjacent. Some other things. A loop is adjacent to itself. Okay. So take a look at example 1. Is A adjacent to B? Is there a line or an edge that connects A and B? Yes. So then yes, they are adjacent. There's a line that connects them, so they are adjacent. Is E adjacent to itself? Yes. A loop makes it adjacent to itself. If there is a loop at that point, then it is adjacent to itself. So yes, because it's a loop. Okay, so if you need that extra explanation, it's a loop, so it's adjacent to itself. Is D adjacent to A? No, there's no direct line that connects the two. And finally, is C adjacent to itself? No, there's no loop. Questions on adjacent vertices? Kimberly, while I totally am 100% for you catching up, you're going to miss today's entire lesson and then have to catch up on that too.
Oh, it's I didn't do it last night. That's why.
I know. Pause it for now. Let's do this today, and then you can go back and finish catching up.
But then I'm going to be confused.
You're not going to be confused. I got you. Okay. Edges. Edges that are adjacent have to have a point that connects one edge to the other. So there has to be a central point that connects the two edges together in order for them to be adjacent. They have to be side by side. So is AB adjacent to BC? Yes. Are they connected by a point?
Yes.
Yes. They're adjacent because I can literally start at A and go A to B and B to C without lifting my pencil. Okay, you have to be able to do it without lifting your pencil. Is CE adjacent to BD? No. When I go from C to E, I can't get to BD without lifting my pencil and then tracing. So this is a no. Question. We're almost done with vocabulary. All right. This is going to be the most important vocabulary of this section. Okay. Degree. The degree of a vertex says it's the number of edges at that vertex. So in other words, if I'm at that dot, how many ways can I leave or go back into that dot? How many lines are coming out of it? Okay. A loop is going to count as 2 because it has an exit and an enter. Okay. So take a look at A. How many lines are coming out of A? 1. So that means it has a degree of 1. There's one way to come out of A. Here. Take a look at B. How many ways can I leave B?
3.
There's 3 different ways. 1, 2, 3. So it has a degree of 3. Go to C. How many different ways can I leave C? 2. 1, 2. Degree of 2. How many ways can I leave D? 1, 2. How many ways can I leave E?
4.
There are 4. Okay. You've got these 2 straight lines, and then you can leave both ways out of the loop. So that makes E a degree of 4. we've got odd degrees and even degrees. If it's an odd degree, that means it's a degree of an odd number. So what are my odd degrees in this picture? A and B. A and B have odd degrees, a degree of 1 and a degree of 3. Your even degrees have even numbers. C, D, and E. Okay, we already did example 7, where we found the degree of each vertex. Label on figure 1. Questions on degrees. This is going to come more into play when we start section 5.5 tomorrow. All right, a path. Bigger. Okay, a path is a sequence of adjacent vertices from a starting point to an ending point. So in other words, I need to be able to start at a dot, trace my lines without picking up my pencil, and ending at another dot where they tell. Okay, every edge can only be traveled once. So once I go down an edge, I can't return back up that edge. It's a no-go. These are one-way streets. Okay, the length of the path is the number of edges that I've traced. So they want us to find a path from A to E. I'm at A. Where do you want me to go?
B.
B,
C.
C,
D.
E. That is one path. A to B, B to C, C to E. How many lines did I trace?
4.
3.
3. I traced 3 lines. Give me another one. Starting at A.
A to B.
A to B,
A to B.
B to D.
B to D,
B to D.
D to E. A, B, D, E. How many lines did I trace?
3.
3. Do you notice a pattern here? If I have 4 vertices, I have 3 lines. Okay, so 4 vertices equals 3 edges. Okay, so keep that in mind. So a path. The difference between a path and what we're about to talk about, which is a circuit, is a path starts at one dot and ends at a different one. A circuit, if you think about NASCAR, always goes back to the start. So a circuit is a path that starts and ends at the same vertex. So you have to go back to the beginning with a circuit. So they want me to start at C, which means when I leave C, I need to go back to C. How do you want to travel?
Go from
C to B.
C to B,
To D.
to D,
To E.
to E,
And then back.
and back to C. So we went from C to B to D to E. I'm sorry. Yeah. D to E and then back to C. I have 5 vertices, which means I have how many edges?
4.
4. Find a circuit for E.
E to D.
E to D,
E to B.
D to B,
B to C.
C,
And back to back.
and back to E. E to D, D to B, B to C, and back to E. Length of what?
4.
Or again. Anybody have another circuit for E?
E to
What?
E to E.
E to E. When you have a loop, that's a circuit if I just travel that loop. So E to E has a length of 1. So if you need anything with a length of 1, you're looking for a loop. A loop is the only thing that will give you a length of 1. Not too bad, right? Awful? No.
You got any food left?
Okay. Try this on your own before we go over. Oh God,
No, I was trying. It felt good.
Oh, I was like, come on now, this isn't that bad.
Right. Like you about to shoot me. Oh my God.
Right. That's because y'all whine. Oh my God, this is so hard.
Hey, you scared from I thought you was gonna smoke me like that. All right, I had to train you up. Started shooting at me. I heard it from my door. They want to shoot it, she go. They stop shooting. She gonna bring the gun outside. They give it to me. It's like somebody rolled by. No, the man is taking like shit. Yeah, rolled by right. I shot him straight in the head. It's so nothing thing. Like I shot him straight.
Work on this, please. Your lift and work.
I'm confused on the first one.
Yes. Confused on the first one?
Yes.
You need to try to get from B to K by going through point W, but you can't go through S.
You can go Z to H, H to J.
You just do not want to go through S. But you're trying to go through W. It doesn't say how long it has to be. It can be as long as you want, as short as you want.
So then go B to W and W to S.
That's what I was gonna do.
You want to go from B to W?
Yeah.
There's no line that goes from B to W though.
Oh,
You can't go through lines that aren't there.
so you can't go from B to H
You've got to go, you can go from B to H,
and then H to J
uh-huh,
and then J to W.
and then W to K, yes.
See, right. It doesn't
Yeah.
go through S.
I thought you were just trying to go straight from B to W.
Well, $30.
When you mean but not S, like you mean not something.
You can't touch
You don't want to touch S at all.
Well, not touch the
The dot. The dot.
Real, You charge your phone. You just ask for the choice.
No, I said I got it. I got my choice.
Yes.
If it wasn't like before, it was already wrong.
5 vertices.
I just noticed, like, I'm pretty tired. Y'all know what Whitehall, North Carolina is?
No, 4 lines.
Whitehall.
Length of 4, which means you need to travel 4 lines, which means you should have 5 vertices.
What did this move for this for that one?
Okay, hold on, Ash.
An hour and 22 minutes away.
So, 5 vertices. Let's just A, B, C, D, E is 4 lines. That line is from A to B, and then you have a line from B to C, and a line from C to D, and a line from D to E. So
Well, that's
it's
what I
fi-
meant, 5 things.
Yes,
That's
yes.
what I meant. Okay.
Okay.
You confused me, that's why, 'cause I was like 4,
Well,
it says 4.
I was trying to get you to bring the right vocabulary
That's why I
out.
was.
Yes.
You said 8.
Did you want us to write all the?
Okay, that's right, that's what
I should agree. No, you don't have to. Just put the numbers in the graph. You're finished? Finished.
So now if it's a circuit link.
Putting on mute.
Smith.
No, I found it. I found it. I don't know what it said. Okay, from B to A,
Huh? You start at B and get to K without going through S, but you wanna travel through W.
That's right here.
Oh, so I gotta make a line.
Uh-huh. They want you to find it.
I found it.
Where's your starting point at B? It says you have to start at B.
Oh.
You've gotta follow what it's saying, Noah. Put your phone away and maybe you could focus a little bit.
So you can't pass this with this.
I found it.
You can't pass through.
You can't pass through S. You cannot pass through the dot S.
You gotta be smart. Look. Bang. 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 I found it.
They want you to touch vertex W, but do not touch S.
For number 3,
But
with
it's
spot.
connected to
So I can't touch the line of S?
No, you can't touch the dot.
Oh, so I can still go through the line.
Yeah, so like I can go from B to H. That's okay.
Yeah, because I thought that was wrong.
You just don't want to touch this dot at all.
So for number 3, when it says find a circuit length of 5, it doesn't matter what order we go in or if we go over
If-
this line.
As long as you don't travel the same line twice. You can go through the same dot twice. You just cannot go through the same line twice.
It says I need help.
What do you need help with?
In the Q50.
In the what? In the what?
But
What are you saying?
I'll sing the song. But I mean, like, oh yeah.
What's up this evening?
Can you see if I did this right? See, look, I'm not good with shapes like at all.
I'm not trying to do any shade.
I know, but if it has anything to do with shapes, basically geometry, yeah, that's not.
This isn't geometry. This is not even close to geometry, my friend.
I know.
You've got this.
Miss Smith. Can you see this?
Y'all do this. Okay. Just be careful here. It says you want to go from B to K.
Oh, okay.
You went to W, continue
Oh.
on. No,
Oh.
you're right, you're right. So you went from B to H, H to J, J to W,
Okay, just go.
and just go to K.
Let's
H to K, K to W, W to J. Be careful, that's only 1, 2, 3 edges. So there's only one to 3.
Could I go back to the
Uh-uh, pass the starting H and go to J. Uh-huh. Now I want you to write down how you get from B to K. You have to somehow get from B to K by passing through vertex W, but not passing through vertex S. J, W, K. That works. H, K. Number 3 is fine. It says a circuit, so if you start at B, you have to somehow get back to B.
Oh,
Remember what a circuit means versus a path. So make sure you're paying attention to that. Same thing with number 3.
How do you do it? Does it have to be in order? Which one I have to do first and
Yeah, you have to give me which way you travel. So you went from B to H, H to J, J to W, W to K. That's good. That's good. Yes. Yes, yes, yes. Y'all are making this a lot harder than what it is.
I didn't want to overthink it.
That's the problem, is y'all overthinking.
Are you checking?
I can. I mean, I still want to go over it together, but I can come around and check yours as you're working.
And it was due back in January. Yeah, and I was just like, that sucks.
I'm gonna say what happened.
Careful here. It's a circuit. It's a circuit. Wherever you start, you have to go back to it. So your starting letter should be your ending letter.
It's not that hard.
Guys, the biggest mistake I'm seeing right now is number 3. You're missing that word circuit. Okay? A circuit means if I started H, my ending letter needs to be H. A circuit has to go back to the beginning. So you can fill in whatever you need in the middle, but whatever you start at is what you need to end at for number 3. Okay, so that's the biggest problem I'm seeing right now. Okay, and make sure that you are traveling the right amount of lines. Okay, every time I go from a letter to another letter, that's one length. That is one edge. So this is why if I have 5 vertices, okay, from A to B is one edge. From B to C is one edge. From C to D is one edge. And from D to E is one edge. So while this has 5 letters, it's only a length of 4. Okay? If that confuses you, you can also write this as AB, BC, CD, and DE. So you see the groupings of 4 if you need to. Okay, so you can write that as lengths instead of as vertices, if that helps.
There, I got it.
Will that help?
Will this be one?
I was sad. I was like, I would know that scholarships or that.
In a circuit.
Yes.
In a circuit, you still can't pass the same dot. I forgot to ask you.
You can go to the same dot as many times as you want, as long as you're not traveling the same line. Okay.
So I'm not dumb.
You're not dumb.
No, he's not. No.
He gets caught up in his music and then
Can
can't.
you come check mine?
That would be something.
It's a rock. It's a rock.
No, I know that.
Then it doesn't have cells.
No, you don't know that. Cause you wouldn't have said it.
You wanna know why?
I don't know why,
No.
like, she has
No.
all this muscle in her
Right,
back.
right.
That's what you keep your head.
A lot of
Right.
Caroline,
Oh,
Eiley, Raquel, yeah.
No, okay, so.
Yeah, I think so.
I'm too high on loud.
Okay.
I was saying, how many issues are there? How many issues?
No,
Okay.
yeah,
That's
bro.
like,
I forgot.
W,
I was-
W, S, S, I mean, travel the same line with that face. You do not travel the same line.
There's some.
Once you
Oh,
cross the
God.
line,
That's like a
right. So be careful with that. Yes, give me 1 second, Tanisha.
You didn't do that before. I'm the least.
Okay, kid,
Yeah, 'cause like everyone in the back would be not.
everybody
Everybody
travel
travel
with S, W.
They'll be like,
Shut up. You just Yo.
You come see if Montessori.
That's why I'm supposed to start some of it.
spot.
But I moved, and like, I moved, and like Blake and Jack would always ask questions, and so she didn't know this time. Yeah, and we were just
I mean,
chilling.
maybe when we asked them questions, I'm just trying to get the information together.
No, we
Asking them questions.
You remember having us do that split brain stuff?
Perfect.
Yeah.
When we did that.
All right,
I
she's coming.
was like, so easy.
Whoop, whoop.
And we were just asking questions like, what if like something happened and like a freak accident and came in that part of your brain? Like, yeah, they even had this lesson. It's like, no, you're asking, we'd be like, look, like, yeah, they'll be all
Well, we so fast, but it ain't
you're
good.
there's a freak accident and you
But
can't
we
happen.
gonna go
You just
like we
lose
should
that
learn.
part.
That's a
Like,
good
what if
term.
the time in one line?
That's my word. 7 people we got right now.
My God,
Right?
Yeah.
I would have hated to get in a class listening to that song.
Miss Mills,
Yes.
can I use the bathroom?
Yes.
Okay.
Okay, let's take a look at number 1. It says find a path from B to K that passes through W and not S. Okay, so I need to hit point W and go through it, but I need to not touch point S. So everybody's pretty much realized I have to go from B to H. There's no other. W, K.
Often the same. I didn't erase that, I'm looking at number 3.
This is yours supposed to be W.
Yeah, I know that now.
Okay, so you've got a couple of different options for number 2. Okay, I want to go from H to J and travel 4 lines while doing so. So I need to start at H.
That's
My
great.
first line goes from H to what?
Okay.
H to K. Again, that's 1 line. So I have 2 dots, but I have 1 line there. Now I want to go from K to where? S. K to S is another line. To W. S to W is another line. And then W to J is my last line. That's a length of 4. So if you need to put the lines underneath to help. Okay, so you could have done that. I also had HKWSJ. So you could have swapped and did W before S. Both of those answers are correct. Okay, a circuit of length 5. You can start anywhere your little heart desires.
H.
Okay, so H. H to what?
J.
H to S. Wait, H to J.
S.
And then S, J to S,
W.
S to W,
K.
W to K,
H.
and back to H. Okay, again, this is a circuit. So your most important thing is, do I start and end at the same spot? We're actually going to talk about this in the next chapter, but I could have also started at J and followed this same exact circuit. I would just end at J. So I could have went from J to S, S to W, W to K, K to H, and H back to J. I could have started at S. I could have started at W. I could have started at K. I could have also done this in reverse order. I could have went from H to K, K to W, W to S, S to J, and back to H. Okay? There are several different ways to complete that. Okay? Your biggest thing is going to remember circuits, start and end at the same letter, and do I have enough lines? So again, if this helps drawing the lines underneath and counting your lines at the end, do that. It is okay to come up with tips and tricks that you think are silly, but if it gets you the right answer, I don't care how silly it is. Okay? I don't care. Number 4, they want a circuit of length 1. If it's a length 1, it has got to be a loop. What's my loop? B to B. Again, please don't just put B. I will mark it wrong. B is a vertex. B to B is a loop. Okay. Last one. Find the degree of each vertex. What's my degree of H?
2, number 3.
There is 3 at H. 1, 2, 3. What's my degree at S?
3.
There's another 3. 1, 2, 3. They're all 3. J is 3. 1, 2, 3. K is 3. 1, 2, 3. W is 3. B is 3. Okay, so they should have all had a degree of 3. Okay, if you need to draw the lines coming out of the dot to count your degrees, do it. Nobody sees your scratch paper on your final. Okay, nobody. They don't care how you got to that answer. They just care that you did. Okay. Questions? All right. We've got 2 more things we've got to talk about, and then we're done. So, connected versus disconnected. We kind of talked about this yesterday. Kind of. Okay. So, a graph is connected if any 2 vertices can be joined by a path. So, this is the way I look at it, though. If my graph is connected, it's all one piece. Let me slam that pen a little bit more. All one piece. If your graph is 2 different pictures, it's disconnected. Okay. In a disconnected graph, the little pieces are called components. Okay. So graph 1 is connected. It's all one picture, all one piece. But if you look at graph 2, we've got component 1 and component 2, which makes this disconnected. There is no line that connects the 2 separate pieces. Is it an emergency? Like, I'm in the middle of notes that I don't want you to miss. Can you wait a second? Okay. This is your last vocabulary for this section. A bridge. A bridge is an edge that connects 2 pieces of a graph. So in other words, if I take away this edge, my 2 graphs now become disconnected. So if I take away this piece, my 2 graphs become disconnected. Okay, so you don't have to go back, but let me go back here. Let me, really? I hate this freaking thing. All right, so let me go back to, I'm trying to go back to one I didn't draw all over. Okay, let me go back to here. Actually, let me shrink this for a second and go to marker. Pen. I want this in white. Okay. So, is there a line in this picture that if I erase it, my graph is now in 2 different pieces? Only one line. Is there one line in this graph that if I erase it, my graph is now 2 separate pictures?
A to B.
If I erase, take a look at this. Where's my white? Oh, really? I need a bigger one than that. I need. Take a look what happens when I erase the line that connects A to B. A is now its own component off on its lonesome, and the rest of the graph is my second component. That means the line that goes from A to B is called a bridge. It bridges the 2 pieces together. Does that make sense?
Yeah.
Okay. Take a look at We've done that one. Take a look at this one. Let me erase this for a second so we can actually see this a little bit better. Let me go back to here.
Yeah, H to B.
Okay.
H to B.
My bridge in this picture is H to B. If I get rid of, where's my little thingy to change the size? There we go. If I get rid of this line, okay, if I get rid of that line that connects H to B, my little loop of B is disconnected from the rest of my graph. So H to B is a bridge. Okay. So let's see what we can do with graph 1 here. Do I have any bridges in graph 1?
Yeah.
Yes. What do I have?
B and E.
B and E is a bridge. So B and E is a bridge. I actually have 2 more bridges in this picture.
What? B to F.
D,
B to F.
B to F is not.
D to E and E to C.
You said what?
D to E
D to E
and E to C.
and E to C. All 3 of these lines right here are considered bridges. If I get rid of this line that connects D to E, D is all by its lonesome, and that splits it into 2 graphs. If I get rid of the line E to C, C is all on its lonesome, and that becomes 2 graphs. If I get rid of B to E, this little angle here would be all by itself, and this triangle here would be all by itself. So that's what makes those bridges. Okay, does that make sense? A little bit more drawing practice.
Oh, Lord.
Oh, Lord. There's only 4.
I'm feeling
Too many.
You don't feel like drawing today?
no. Not done.
How about I just have somebody come up and do each one of these and we'll be finished?
Yeah.
I'll do one.
Who wants to come up and do number 1? I think I have to fix the board again, huh?
It's okay.
Because you know my board hates me.
But your board really don't.
It really doesn't. It hasn't liked me since I started
What
here.
are we doing? Drawing.
Those last 4 examples.
Oh, I used to just hit those things like, do we have to hit where the X is? Like,
Yes, or else it doesn't calibrate right.
Like,
Hey.
We have to draw our own shape.
Yes, it can be any picture you want. 3 and 4 are the easiest. Oh, I'm sorry, there's 6 of these.
That's a lot of work.
Let's at least do a couple of them.
6 vertices. 6 dots, right?
6 vertices means 6 dots. Yes, ma'am. And 6 edges means you connect those dots with 6 lines.
I think a little would be straight on.
I'm gonna go put it up. Go, girl.
I don't know what I drew, but okay.
Be careful, it says 6 vertices, you have 7. You have 7 vertices, it says 6. Guys, you have got to be careful. If it says 6 vertices, you can only have 6. You can't have 7, you can't have 5. It has to be 6.
that's
Okay? So, this one works for number 1. Okay? Take a look at what I had on my paper, and then Isabel's going to come up and do the second one. Okay? Both of these would work for number 1 as well. Okay? It doesn't matter what it looks like as long as you have everything that they're asking. So you need to have 6 dots and 6 lines that connect them. Okay. Go ahead, Isabel. Go, Isabel. Go, Isabel. Woo woo.
This table.
Beautiful. Okay. So my suggestion to you is when they get specific and tell you they want 2 bridges.
Do your bridges first.
Okay. Do your bridges first.
Right.
Your bridges should just be lines that extend out to a point. Okay, so that was the first thing she drew. She drew a bridge here and a bridge here. Don't mess with these 2 points ever again, and you'll never mess up your picture. Okay, so when I reach out to those points and make those bridges, don't touch those 2 points that we've reached out to, and you're golden the rest of the time.
So the other dots have to be connected.
The other dots have to be completely connected and closed off to make them not bridges. So that's why she went through and circled the rest of these. Okay. Let me show you some other examples of 2 bridges. All 3 of these graphs have 2 bridges. It doesn't say whether it has to be connected or disconnected. So this one on the left is a connected graph with 2 bridges. Here's bridge 1, here's bridge 2. This one here is also a connected graph with 2 bridges. Here's bridge 1, here's bridge 2. This one down here is a disconnected graph with 2 bridges. If I erase this, this disconnects those. If I erase this, it disconnects those. All 3 of these work. Okay? Doesn't say my graph has to be connected or disconnected. It just says I have to have 2 bridges. Well, there they are. Okay. All right. Who wants number 3? 3 and 4 are probably the easiest ones on here. Kimberly will do the first one. Go, Kimbo. Go, Kimbo. That's going to be her new nickname, Kimbo. Oh, yeah? Sorry, I missed that. Yes, be careful with this one. You do have to label your vertices in this one because it tells you to. Perfect. You should have dots, A, B, C, D. And then she has a line that connects A to B, a line that connects A to C, a line that connects A to D, and a line that connects B to D. Perfect. Who wants 4?
I'll do 4.
Go ahead, Kimbo. Go, Kimbo. Go, Kimbo. Woo, woo. Woo, woo.
R, S, and T. Okay, so P to Q, Q to R, R to R.
Perfect.
R to S, T to S, and then T to P.
Perfect. Okay. This one had 5 dots. P, Q, R, S, T. P to Q, Q to R. R to R is a loop, so she put a loop at R. R to S, S to T, T to P. Number 5. Okay. Let me talk about these 2. 3 even vertices and 4 odd vertices, which means I need to have a total of how many? 7. I need to have 3 and 4. So I need to have 7 dots. Okay. 3 of these need to be even vertices. So they need to have an even amount of lines coming out of them. I pretty much, when I need even, do something like this. If you just draw a circuit that goes from one dot to the next that I need to connect, that makes them even. There's 2 lines coming out of this dot, 2 lines coming out of this, 2 lines coming out of this. Okay. The next one has to be odd vertices. And this has 3. There's your 4 odd, 3 even. So if it's an even vertices, make them connect in a circuit. If they're odd, just kind of span them out like, I don't know, fingers. What do you want to call that? Spiderweb. Okay. Number 6. They want to know the difference, if you know the difference between connected and disconnected. Okay. So same criteria for both. It's just one's connected, one's disconnected. So I need 5 vertices. 2, 3, 4, 5. If it's 5 vertices and it's connected, make it a circuit. That always makes it connected. So here's 1 edge, 2, 3, 4, and 5. I need a total of 8, so just add some extra lines then. 6, 7, 8. Okay. If you make it a circuit with all of your dots, it will always, always be connected. For disconnected, I take a set of dots and put them together, and I leave one little dot all on its own because that always makes it disconnected. If I have an isolated vertex, this will always, always be disconnected. So just pick one dot and never touch it with a line, and you're good. Again, 8 edges. 1, 2, 3, 4, 5, 6, 7, 8. And it's disconnected because you have that isolated vertex. Question. Okay.